Welcome to The Explainer. Today we are peeling back a layer of reality itself to look at one of the most incredible, mind-bending objects in all of modern physics, the D-Brane. I mean, these things started out as just a mathematical curiosity in string theory, and they ended up completely revolutionizing the entire field.
So, to get our heads around this, I want you to just think about something for a second. We usually picture space-time as this perfectly smooth, continuous fabric, right? But what if it isn't? What if, hiding inside the universe, there are these hidden surfaces, these membranes of different dimensions that actually shape the very laws of physics?
Well, in string theory, these cosmic seams are very real, and they're called D-Branes. You can think of them as physical surfaces that act like anchors. So an open string, which has two ends, has to have those endpoints fixed to a brane. It's basically stuck. But a closed string, a tiny little loop, that's totally free. It could just float anywhere it wants in the surrounding space. And this single distinction, it changes absolutely everything. All right, so here's our game plan. First up, we'll get into the fundamentals. What exactly are D-Branes? Then we're going to explore the strange magic of duality that they helped uncover. After that, we'll take a deeper look at the rules they play by, their charge and action. And finally, we'll see what happens when these incredible surfaces actually interact with each other.
Okay, so to really get a handle on D-Branes, you have to understand that string theory kind of outgrew its own name. Physicists began to realize that the universe couldn't just be described by these tiny, one-dimensional, vibrating strings alone. The theory itself was crying out for something more, something bigger.
And that something was the D-Brane. So let's break it down. A D-Brane is a dynamic object. The D actually stands for Dirichlet, which is just the fancy mathematical name for the rule that nails the ends of an open string in place. And brane, well, that just comes from the word membrane. But the P in P-brane is super important. It tells you how many spatial dimensions the brane itself has. So a D0 brane is a point, a D1 brane is a line, a D2 brane is a plane, and you can keep going, all living inside our higher dimensional space-time.
Now, the really crucial thing to get is that these are not just some passive background. No way. D-Branes are real, dynamic, physical objects. They have tension, which means they fight back when you try to stretch them. Their very existence can mess with the perfect symmetry of space-time. They carry a very specific kind of charge. It's called RR charge. And maybe the wildest part is that the vibrations of the open strings that are stuck to them can create entire worlds of particles and forces, what physicists call a gauge theory, that live right there on the surface of the brane.
Okay, this is where D-Branes went from just being an interesting idea to being an absolutely essential part of the theory. They turned out to be the key that unlocked one of the deepest, most powerful ideas in all of physics, duality. And duality is this amazing concept that two theories that look completely different on the surface can actually be describing the exact same reality.
So the first and most famous example of this is called T-duality. And, this is a truly bizarre idea, so stick with me. Imagine that one of the dimensions of space is curled up into a teeny tiny circle. T-duality says that the physics in that universe is completely, totally indistinguishable from the physics in a different universe where that same dimension is absolutely enormous. Yeah, from a string's point of view, a tiny radius is the same as a huge one. Small is big, and big is small. It's nuts. And this duality connects things that seemed totally unrelated. See, physicists had these two different versions of superstring theory, called type IIA and type IIB. They looked like separate theories, but T-duality proved they're just two sides of the same coin. You apply the duality to IIA, and it turns into IIB. You do it again, and you're right back to IIA. And the key difference between them? It all comes down to their D-Branes. IIA theory has branes with an even number of dimensions, while IIB theory has branes with an odd number.
And this isn't just some math trick where you shuffle equations around. Oh no, it has real physical consequences. If you take a D1 brane, which is basically a string, in one theory, and you apply T-duality, it literally transforms into a D2 brane, a whole plane, in the other theory. And the transformation doesn't just change its dimension, it can even slap on new properties, like a magnetic field, right onto the brane's surface.
This was a total revelation. It meant that the 5 different string theories physicists had come up with weren't really separate at all. They were just different ways of looking at one single underlying framework, what we now call M-theory. D-Branes were like the Rosetta Stone that let us finally translate between all these different perspectives.
So if D-Branes are real physical things, they've got to follow some rules, right? Let's take a look at the physics that governs how they actually behave.
And just like pretty much everything else in the universe, it all boils down to fundamental properties like charge and action.
The easiest way to think about this is with an analogy. You know how an electron has an electric charge, and that creates an electric field? Well, a D-brane has something called an RR charge, and it acts as the source for a special type of field that exists in string theory, kind of like how a magnet is the source for a magnetic field.
And this charge has a really fascinating property. It's quantized. That just means it only comes in distinct, whole number chunks of some fundamental unit. This is actually explained by something called the Dirac quantization condition, a really beautiful piece of physics that was first developed to figure out if theoretical magnetic monopoles could exist. Turns out, the exact same logic works perfectly for D-branes.
Okay, so charge tells us how a brane affects everything around it. But what tells the brane itself how to move? Well, that's governed by its action. And for D-branes, we use the Dirac Born-in-field action, or DBI action. We don't need to get into the messy details of the equation, but you can just think of it as the ultimate rulebook. It contains all the info about the brane's tension and exactly how it should respond to all the forces in space-time.
All right, so now that we know the properties and we know the rules, we can finally ask the most exciting question of all. What happens when these things actually meet? Because the interactions between D-branes, that's where some of the deepest and most profound ideas in string theory really come to life.
One of the very first things you find is that geometry is everything. I mean, the force between two D-branes depends critically on the angle between them. This isn't just a simple case of they attract or they repel. The interaction is way more rich and complicated than that.
And this leads to a whole zoo of crazy possibilities. If you've got two branes that are perfectly parallel, the forces between them can cancel out exactly, creating this perfectly stable no-force situation. Physicists call that a BPS state. But if they're at an angle, they'll either attract or repel. If you bring a D-brane near its opposite, an anti-D-brane, they can just annihilate each other in a flash of energy. And maybe strangest of all, they can actually intersect and merge to form totally new, stable, bound objects. And this is where it all comes back home to us. Because a really popular idea in some parts of string theory is that our entire universe might just be a D-brane. And when these branes intersect, the little open strings stretching between them can vibrate. And the lowest energy vibrations of those strings, well, they look exactly like the fundamental particles and forces that we see all around us. These interactions could literally be the engine of creation itself.
So, let's just quickly recap the journey we've been on. We started by discovering D-branes as these mandatory anchor points for open strings. Then we saw how they became the key to unification, showing us through T-duality that all those different string theories were really part of one big picture. And finally, we saw how their interactions could be the very source of the particles and forces that make up our reality.
And that just leaves us with this one final, really tantalizing thought. For decades, D-branes were hiding right there in plain sight, inside the mathematics of string theory, just waiting for someone to understand what they were. And their discovery changed everything. It really makes you wonder, what else is hiding in the math? What other, even deeper layers of reality are still out there just waiting for us to find them?